In this lesson, I'm going to show you how to solve a quadratic equation by factoring when a does not equal 1. Notice that we already have a nice setup on number 1, where all of my terms are on the left-hand side of the equation and it's set equal to 0, so I can successfully solve for the zeros of this quadratic. The first thing to check for always is a greatest common factor, but I'll just tell you right now that this particular quadratic here does not have a greatest common factor. 5 does not go evenly into 37, and it also does not go evenly into 24, so there's nothing that we can divide out of each term. So now I need to identify a, b, and c and set up my x problem. A is the number in front of the squared term, b is the number in front of the linear term, and then c is all by itself hanging out at the end. I'm going to make sure to include that negative sign. Now we set up our x problem. Remember that a times c goes on the top, so the top of my x problem is going to be negative 120, and then b goes on the bottom. Now we need to list factors of 120, or things that multiply to get 120. For the moment, I'm going to ignore the fact that that 120 is negative. Now again, if you don't know off the top of your head some factor pairs, you just start listing them in order. Okay, so the first thing I could think of is to divide by 1, and I would get 120. Then you try dividing by 2 to see if that works. That would be 2 and 60. Then you try dividing by 3, 3 and 40. Then you try dividing by 4, 4 and 30. And this one's going to have a lot of factor pairs just because it's fairly large. Let's try dividing by 5 and see if that works. Yep, we would get 5 and 24. Then you would try dividing by 6. That would be 6 and 20. 6 and 20. You would try dividing by 7, and I can tell you that that's not going to work. Try dividing by 8, that will work. That would be 8 and 15. And you can see our numbers are slowly but surely getting slightly closer to each other. You would try 9, that doesn't work. You would try 10, and that would be 10 and 12. You would try 11, that doesn't work. And then the next number after 11 would be 12. And note, 10 and 12 and 12 and 10 are the same factor pair. So we found all of our possibilities. Now, since the top number is negative, that tells me that one of my numbers is going to be negative and the other number is going to be positive. And we're looking for two numbers that are 37 apart. Okay, so and since the bottom number is positive, that tells me that my smaller number would be negative. So we're looking at one of these numbers being negative in my factor pairs. Just scanning through, if you need to add them all together, that's totally fine. But just scanning through, I notice that 40 and 3 are 37 apart. And 40 minus 3 is 37. And 40 times negative 3 is negative 120. So my options here are negative 3 and 40. Again, you would check just to make sure, is it true that those two numbers multiply to get the top and add to get the bottom? Yes, sure does. Now remember, the whole purpose of the x problem here is to rewrite this middle term into this guy and this guy. Right, so I'm going to rewrite the trinomial. I still have 5r squared as my first term, but now in the middle here, I have a minus 3r plus 40r. This could be reversed. It could be plus 40r minus 3r. It doesn't really matter. And then I have minus 24, and all of that is set equal to 0. So now I'm going to take that information there and plug it into my 2x2 box. I'm just going to work in order. So the first term goes in the first box, the last term goes in the last box, and then I can split up the middle two however I want. Again, I'm just going to write it in order. So the negative 3r first, and then the 40r along the bottom. Now we need to find the greatest common factor of the rows and columns and write it outside. So I'm going to look across along the top there and say what number goes into 5 and 3 evenly. Well, the only number that goes into both of those is 1 because they're both prime. So I can take a 1 out of each of those. And then the other thing they have in common is they both have an r. Now looking up, I'm trying to find the greatest common factor of 5 and 40. The only number that go into 5 are 1 and 5 does go evenly into 40. And they also both have an r. Then I'm going to just pause for a moment and check. Is it true that 5r times 1r is 5r to the power of 2? Yes, it sure is, so we're good so far. Now let's go ahead and take a look along the bottom row there and see what's in common between 40 and 24. Again, if you don't know these pieces off the top of your head, you can watch one of my other lesson videos on finding a greatest common factor, right, where we use prime factorization to break it down, see what's in common, so on and so forth. That's totally an option. But hopefully you're able to see just by looking at it that the largest number that goes into both evenly via multiplication is the number 8. And then I'm going to look up here and say, what's the biggest number that goes into 3 and 24? Again, 3 itself is prime. Notice that both of these numbers here are negative, so I'm going to actually take out a negative 3. Lastly, I'm going to do a check and make sure that negative 3 times a positive 8 is a negative 24. It indeed is, so we perhaps factored correctly. Now, written in factored form, our new expression looks like this. Again, it doesn't matter which one comes first, but I'm just going to write r plus 8 in the first set of parentheses, and then the 5r minus 3 in the second set of parentheses. Looking back at my original problem, remember we're trying to solve each equation by solving for the zeros, so I'm going to set those equal to 0. Now, remember using the zero product property, either factor has to equal 0. They don't both have to equal 0 at the same time, so I can write two separate equations, one that says the first thing in parentheses equal to 0, and the one that says the second thing in parentheses is set equal to 0. And now I'm going to solve both equations. That first one's really easy to solve. It's just a one-step equation. I need to move that positive 8 to the other side by subtracting. 0 take away 8 is going to be negative 8. So one of the options is that r equals negative 8. That's one solution. The other one's a two-step. Notice I'm going to move that negative 3 first because it's further away from the r. The way I'm going to move it to the other side of the equation is by adding. 0 plus 3 is a positive 3. I'm going to drop down that 5r. We're not fully done solving it because r is not quite by itself. The way I undo that multiplication with 5 times r is by dividing both sides by 5. And now if you type that into your calculator, you're going to get a decimal. So we're actually just going to leave 3 over 5 as, well, 3 over 5. That's the best way to write that. So my two solutions, which we can write in braces like that, let's list the negative one first, are negative 8 and positive 3/5. And I promise if you take those numbers and plug them into the original equation, you would just plug negative 8 in for r there and there, and evaluate, you should get 0. And then if you did the same thing with the 3 over 5, plugged it in there and there, and evaluate, you should get 0. And that's how you solve a quadratic equation by factoring when a does not equal 1 using the x problem and box method.